Welcome to the JAMOVI R JASP workshop. I'm glad to see you here. I think this is one of the biggest workshops that I've done so far, so that's nice. I usually give these workshops in a classroom, in a hall, but these are uh, different times, so we're gonna do this remote. I want to say at the onset that I'm not sure why, but sometimes when I run stuff on Zoom, it tends to crash, especially as I open JAMOVI and R and Chrome and other stuff. So if I somehow get stuck and I disappear, don't worry, I'll come back. It just sometimes my computer gives me a little bit of issues. But I do ask that you please mute your microphones so that we'll be okay and can proceed. All right. Before I begin, I just want to tell you that this is the second workshop that I'm giving remote at HKU. The other one was last week. You're very welcome to go and watch this. So everything is on YouTube. Everything is shared. All the cloud folder and the slides are there. So this is the URL over here. You can just go and have a look at that. Also, everything that I do this semester is also available on YouTube and on the Open Science Framework, which is a data sharing site. So if you want, you can go on here and see some of the lectures that I'm giving. I think the most important one that I would urge you to have a look at, because we won't have time to look at this today, is about the science crisis. So did you know that there's a science crisis, a so-called crisis? At least there's what we refer to as a credibility revolution that tries to change the way that we do science, improve our practices. And one of the ways to improve our practices is to work on reproducibility and sharing of everything that we have. And I think R and JAMOVI and JASP are really good tools that help us to go in the right direction. So what is this so-called crisis? What is the credibility revolution? What do we do here at HKU? All this is in a 1.5 hour sort of talk that I give at the beginning of each one of my courses. And then together with the students, we work together on doing all sorts of things in order to promote, do hands-on open science as early as second year undergraduate. So with our students, the first time when I decided to run these kinds of courses, I came into HKU, and it was very clear to me that some of the classes are still done with SPSS, and there was one attempt to move to R, but that sort of failed. So reverting back to SPSS, but at least in my courses, we've been implementing JAMOVI with my guided thesis students. I've also been insisting on using R. So there's reasons for that, and I think it's really important that we try and train our students at HKU and elsewhere in Hong Kong and whoever else is joining from elsewhere to really transition from paid closed tools like SPSS, SAS data, and all those into open code, open science tools like JAMOVI and R, and I'll try to demonstrate to you why this is important. But if you want to know a little bit more about what we're doing in the courses, you're very welcome to watch this. So this is intended mainly as a JAMOVI workshop, but I do feel like it's important for me to share with you that we also have these amazing tools called R and JASP. I'll talk a little bit about what's the difference between JAMOVI and JASP. They're quite similar, but R is a programming language that we've adopted in order to conduct our statistical analyses. It's a very powerful programming language, and I think it really was boosted in the last few years and took over what most of us do in terms of statistics and psychology and science overall. There are some people who prefer Python. It's a whole debate which one is better. But I will say that at least in the psychology field, if you don't have very advanced data analytics, I think R is the way to go. I won't go over the slides too much. I'm just going to give you a hands-on demonstration. But the few slides that, like, if you download the slides, just know that I borrowed these from all sorts of sources. So the JAMOVI team, the JASP team, and a bunch of other really amazing sources that you have over here. All of them are in this cloud folder. So I think one of the first things that I'll do is just show you what's in this cloud folder. So if we go over here, let's just close this for a second. Yes. Okay. So if we go over here into the cloud folder, if you downloaded the cloud folder, this is what you'll have in it. So JAMOVI, JAS, the presentation. So if you want this presentation, it's in 2020. So it's this one over here. Some R magic, which I think is the first thing that I'm going to do in order to show you how far R has come in recent years to be easier for you. And then the recommended courses, which I borrowed from, there's a bunch of links over here. There's also some stuff about open science with profanity, statistical rethinking, and all that. There's also some good R courses. So the Data Lab is, I would say, one of the greatest courses that you can do in order to boost your statistical skills, especially if you're in a very, very basic level. I should also say that if at any time during this talk you have some questions, you're welcome to open the chat room and then ask me about that. Student JAMOVI, okay, yeah, I took from some students, and then some statistics resources about how to do all sorts of things, like how to quantify the null and run statistics for psychology. So there's a bunch of books in here that you can do, and some of them do use JAMOVI and JASP, so they demonstrate all sorts of things. Maybe I should remove this one about using SPSS. Don't use SPSS, or don't use annotated SPSS. Just use JASP and JAMOVI. Okay. So this is what we have in the cloud folder, and then little by little I will use some of those so you can try and follow up. Okay, so we have all of this. This is not okay. Okay. One more thing that I'll show you before we begin is that I'm going to show you a website. This is my website, so. It has a lot of resources. So I'm just going to show you how you get to these resources. So let's say you don't have the direct link and you don't know how to access these sort of things. How do you find things in terms of what it is that I offer? So you can see that this is my main website. On the left, there is this sidebar that you can go into. And this project that we've been running here at HKU with all the other students is called this mass replication and extensions. I'll click on that first, and then I'll show you some of the resources that we have. So if you just open that, I can feel the website is heavy because it's under heavy use now, so that's good. You can see that there's something called Get Involved Resources. So once this whole page loads and you go to Get Involved, you'll see that it opens this Airtable, and in this Airtable, there's a bunch of things that you can use. And you can see that we have a lot of guides over here. So we have all sorts of examples from the students from 2019, 2018. So if you want to see what our students did with JAMOVI, you're very welcome to just like open these websites and have a look. And as you'll see, it's just like a cloud folder, so you'll be able to open this. I'll show you in a second what's included in there. And another thing that you can do is use one of our many collaborative guides. So let's say that you want to do a replication extension, just like the ones that we're doing with our students at HKU. Then you're very welcome to go to this guide over here, the HKU JAMOVI JASP R guide. Sorry, this replication guide is over here. And then we also have a collaborative guide for our JAMOVI and JASP, and I'm going to open this in order to show you what's inside. Now, all of these collaborative guides are, well, collaborative, so all of you can go and contribute. So I kind of set the frame, I kind of built the Google Doc, but then any of you can come in and edit this as you see fit. So you can see that there's a place for you to kind of, if you contributed something, like some of the students that are working with me, you can just add your name in here. And at some point, if we submit some of this to some journal, then you can be a co-author. But this guide especially is not very complicated. It just includes a bunch of links. So if you open this JAMOVI JASP RR Markdown, you'll see that there's a lot of stuff going on over here. And what's nice about this is that it doesn't depend on me. So it doesn't, like, if I'm a little bit out of date in the sense that, I gave this workshop 2 years ago, and since then I've made some little tweaks here and there. But if you want to see up-to-date stuff, this is updated by the community, and there's a bunch of stuff over here. So in terms of, like, if you want to read books, some of them are recent books, videos, all these links, workshops, but also every time that students ask me for advice, rather than just telling them, okay, this is what you should do, I go onto this guide and I update this over there. So for example, if students ask me, so how do I do recoding? So if there's some code, a little bit of code involved, I just post it over here. So you'll see that there's a bunch of things with screenshots and other stuff. So I strongly recommend that if you're interested in JAMOVI, JASP, or Markdown, you'll just like go over through these things. And here on the left, you have a bunch of things. Like, for example, if you want to do some advanced plotting, there's a few things that I'll show you in JAMOVI, but there's like a bunch of other things that you can do over here, and it will give you step by step. Finally, I think the most important section that I think it will be the most helpful for you if you want to transition to R, is this RStudio section over here. And at the beginning, we didn't have too many nice things over here, but now we really do. So you've got a million books about R, and courses that you can take, and workshops, and just a lot of examples about all sorts of things on how to do this, including some code to help you do things a little bit more efficiently. So just go through this whenever you have the time, and just know that it's available, and just know that you can edit this. So it's available to you not only to use, but also you can send your students, your collaborators over here, so that together as a community we'll update this. And I think by now, like, we have about 20 people who are working on this and updating this. So hopefully by now it's up to date. Some really advanced stuff, like recent stuff like the multiverse, how to do this, how to do visualization, advanced stuff. So this might be helpful for you. If you want to see some examples from our students, the previous link that I opened, this is an Airtable, and you can see basically that we replicated all of these over here. So 22 students, 22 groups of students, undergraduate, that worked on replicating classic effects in judgment and decision making in social psychology. So for example, overconfidence, illusion of control, feeling that you have control when you have none, false consensus, and all that. So we've done a bunch of replications for every one of these targets. We did it once with M-Turk Americans, and another time with a prolific academic, and we had quite big samples. But then you can go and see their pre-registrations and see their reports. And if you open just any one of these, like for example this Dropbox, so everything that we do is open science, completely shared. You can go and download this and use as you want. You can see that a lot of these projects actually have JAMOVI files in there. So all these OMV files are JAMOVI files. So you can see how the students actually did their projects. So all this is just available to you, and everything you can come and explore from this main web page on my website. There's also a bunch of stuff on how to do extensions. I think this is a really good one about how to calculate effect sizes, confidence intervals, how to do a power analysis. So this is a very powerful guide that you can use in others. And this too is collaborative. So if you open this up, you'll see that it's under active development. So Chinyu over here is leading this effort. And by now we have a lot of examples about all sorts of things. So if you want to know how to calculate effect sizes for t-tests, for constant, proportions, for ANOVA, correlations, and also if you want to know how to do power analysis, both with R and with G-Power or some Shiny apps, then everything is here available for you to use as you wish. And again, it's collaborative, so if you end up contributing something, just please add your name over here, and when we submit this, you'll be a co-author. So everything is really collaborative. You can see over here we have a new collaborator, so that's terrific. We really encourage this. So everything that we do here at HKU is built for you to come and to contribute. So this is the first page that I wanted to show you. I also want you to know that we have some templates. So if you want to write a manuscript about a replication or about a meta-analysis, then we've built some templates that you can just take and adopt for your own thing. Lots of options for you. Another thing that I want to show you is that there's a bunch of workshops. So there's a workshop page over here. And if you go on this workshop page, you'll see, going a little bit slow. Okay, so I give some workshops about meta-analysis, and then the one that I gave last week about pre-registration. So I give this in different places, but if you like click on these URLs, you can just access the cloud folders and just take everything that we do. Hopefully it will be helpful for you in some way, or if you give your own workshops, that's terrific. We really encourage this. Also, teaching in courses, everything that I teach is completely shared, not just the stuff that I do, but also the stuff that my tutors do, and everything that the students do during their coursework in terms of their presentations and their handouts. Everything we try to submit to journals and open up for the community to get some feedback. So it's over here if you just open the teaching tab. Oh wow. Yeah, my website is now a little bit slow. I don't think it ever had 100+ people trying to access stuff. So, but yeah, just know that it's there, and it's available for you to use in any way that you want. Okay, let me see what I want to do now. Yeah, so this webpage I just showed you right now, it's this webpage that kind of summarizes everything about our project at HKU, and the students' examples with the JAMOVI is through this URL over here. So the teaching in the courses, I'll just show you that at the end, this is from this semester. The nice thing about this semester, although it's kind of tragic that I don't get to meet my students and see them face to face, doing remote has its advantages. So everything is recorded. So if you just open these open science framework links, you'll see that on the wiki here, all the lecture videos are here. So the science crisis, the misunderstanding of statistics, evaluation of findings, so forth, everything is shared on the open science framework, and you can just like access all the course materials and all the tutorials. So we have 3 great tutors that give some stuff in addition to my lectures. So there's a lot of stuff that's available for you to just take, share, adapt, do whatever you want with it, and hopefully promote open science in your own universities and classes, courses. All right, so I think this is like a good enough promo. I'm going to a little bit later ask you some questions to answer on the Mentimeter to try and help me understand who you are and what your needs are. But as a first step, I'm going to close this Chrome because otherwise my computer is going to start doing some nasty stuff. I think I'm just going to dive in and show you some things. I'm going to start with R rather than JAMOVI, because I think a lot of people are scared of R. I don't know why, but I think it has this kind of reputation, especially if you don't have a computer science background, or if you haven't like approached this at a young enough age where you have an open mind and you're willing to test some code. I think it's that there's like a barrier that you need to go through. I want to show you briefly some tools of how simple R can be. The only thing that you need to do is just like a little bit of setting up to do. So once you've downloaded the RStudio, you have this kind of interface. Now I loaded one of the R files that I'm going to demonstrate to you. It's called 2020-03. I'll just show you where it is. Yeah, so if you go to this R magic, So under the main workshop, there's an RMagic folder, and under it, you'll see that there's Gilad's RMagic for workshop. So if you downloaded RStudio, and if you've even if you have R, you can kind of open this website, and together with me follow a little bit. Now, if you don't want to, that's completely okay. I'm just going to demonstrate some stuff. I'm not going to go into this in detail. I just want to show you how far R has come in order to, help you do things easier. Somebody's saying on the chat that it's scary. Yes, all these codes. So if you've never seen code in your life, this is pretty scary. But the good thing that you need to, just looking at this whole thing is that if you see this kind of hashtags, then you know that this is a comment. Each one of those is a line that you can execute. So if you stand on a line and then you do run, it just runs this line. So let's say that you have a code snippet and you just want to run that code. The only thing that you need to do is stand on the line and then run this over here. You can also do Control-Enter if you just want to quickly go through those. You can also select a few lines together and then run them. Over here on the right side, what you see is that you have a bunch of things about the environment. So let's say all sorts of things about the variables that you loaded, the data sets that you have. So right now, for example, in RStudio, it's very easy because you have, if you want to see, so what is this data over here? Let's just open this up. So if I click on this, actually it shows you the data. So even within RStudio, you can already see that there's some like easy interface for you to quickly do stuff that in R previously you were not able to do. Now I'm going to clean this up, and I'm going to clean this one up because we want to start fresh. So if I press this broom thing, then it kind of resets the whole thing. Now, R is a framework. It's a programming language. And the nice thing is that each one of us has our own code. See, we work on our stuff, but then there's an ability for us to share some code with others and then wrap it up in something called a package. Now, all of these things over here, there's car and psych and ggplot2, all these things are packages. Right now, it's not really important for you to understand what it is that they do, but usually before you start using a functionality, you start using something by a package, you need to first install it and then run it. So this line here, all these 4 lines over here, what they do is that they install these packages over here. Now I'm going to start from these lines of code. It sets some options, and finally the main thing that it does, it tells RStudio where my files are. So basically it tells RStudio that I'm going to point the directory, set the working directory to the same working directory as the R file. So if we just run this, we go over here to run, you'll see that it runs this and it sets the directory to this directory, which is where we stand right now. Now, what's the difference between R and RStudio? Somebody asks on the chat. And the difference is that R is the programming language. Actually, I'll show you what R looks like. So if we'll just go over here. Just today, I did a very risky move of installing the new R. So this is what R used to look like. And I think once people saw this, they say, okay, I give up. That's the end. Let's forget about R forever. And the problem is that there's actually very little feedback over here. You just, it expects you to start typing, and there's not a lot of debugging that you can do. It doesn't give you a lot of information. So R runs on the bottom, let's say it's the foundation, and then RStudio kind of runs on top of this and just allows you to edit your R files, so the code files. It allows you to get some information about your environment, so what's loaded, what's not. And then as you can see over here, there's also information about all the packages that are loaded, all the files that are involved right now. In the working directory, all the plots, and I'll show you a little bit of that. If you want some help, you can find some help about this. So I don't know, like say you want help about, so what is this install packages? Let's look at this over here. Perhaps it can give me some help. And it says, yeah, this will install packages from the repository or from some local files, especially there's this repository called CRAN. But I think we're getting ahead of ourselves. This is a little bit like too advanced. I don't want to go into R. This is not the point of this workshop. I do want to show you, let's say that you are starting over here and you want to like get a sense of how do I work with R? What do I need to do? A good way to start with R, which is one of the first things that I did, is this package called Swirl. You can load this and then finally run it. And we'll do this together. I just want to show you how it teaches you how to do some stuff in R. So if I'm just gonna run this, you see that it runs all these things. And now it asks me this question. So what should I call you? And because people call me Philly, my name is Philly, I write Philly. So it asks me, so what kind of lessons do you want to have? And let's say I just want to like do basic building blocks. You can add some stuff afterwards. So you just do R. So to assign the result of 5 plus 7 to a new variable, just type this thing. So you can like just you type this sort of thing, and it says nice work. You'll notice that R did not print the result of 12 this time because you used the assignment. So it just like takes you step by step, and then he says, in order to view the contents of X, so you did this kind of assignment over here, then write X, and then it puts you. So it just takes you step by step through everything in R. And it shows you how to do this within the syntax of R. So that's like a really nice way of, rather than somebody, taking you outside and showing you a video and saying, you need to do this, you need to do that. This just takes you step by step in our syntax mode over here. So you can just like follow these sort of things and then follow this whole thing until you feel that you know what you're doing over here with R. It's like Python command line and IDE. Yes, very, very similar. Actually, it's a very controversial move, but RStudio now can run Python. So if you want to mix R and Python, you can actually do that. So it's really, RStudio is an IDE for R. Very much so. You can also, like following up on the library Swirl, you can install some other courses. And then, it will give me some information about how to install courses, what to do in terms of just explaining some of the commands. So every time you see a function and you're not sure how to use it, you can just do a question mark and then install courses, and it will give you the documentation, and then you can find some stuff and search. So just like use the search best you can. It's very functional. It's nice to have this over here on the right. Now, some of you say, okay, I've been using SPSS and now I want to transition to R. It's going to be really difficult for me to load all my data sets. Not necessarily, because now we have something called a tidyverse. It's this framework that allows you to very easily load SPSS files. So SPSS files end with .sav. If we go over here, we can see that we have some SAV files, and we can load them if we want to. So you can just like load things and put them into this data sets. Load Haven, and then load the empty cars. So the only thing that I needed to do, which I haven't done, which is because things were closed, is that I had to first set the working directory, which I did with these lines over here, and then I loaded the package that allows me to read SAV files. Once I ran this command, so I just went over here and ran this, what it did is that it put the file of empty cars.sav into empty cars here. So if we look over here at the global environment on the right side, you would see that you can just like click this, and then you can see what's in empty cars, what's involved in all of this. So as you can see, this is a very, very simple syntax. The only thing that you need is this file name. There's this function over here of read SAV, which, just like I said, that you can do this kind of thing, and then just like run this, and then it will open this over here on the right. So read SPSS file, and then it will tell you this is how you use it. You read SAV with a file and all that, and then read SPSS. So you can very easily load your data sets, and then you can start manipulating these in all sorts of interesting ways. You can also do this with CSV files if this is what you use. The nice thing about these the loading SPSS file is that it already loads all your labels and all the data structures. CSV does not have that. So it just makes it so I instruct all the students working with me to load the SPSS file. There's advantage in that, in the sense that if you load an SPSS file, it just comes with everything in it. Also, R includes a lot of built-in data sets. I want you to remember this tooth growth, because I'm going to show you tooth growth data set also in JAMOVI and in JASP. So we'll keep coming to this, and this is a good data set to demonstrate how to use ANOVA and t-tests. So you can load the data sets by running library data sets, and then you can just like look at the data in tooth growth. So and then look at the structure. So str just shows you a little bit of the structure. So we have this variable and this variable and this variable. So by now you're thinking, oh God, he said this is going to be easy. This doesn't look easy because I need to like understand the syntax, and then I need to look it up, and like this is not the kind of easy that I was looking for. But I just want to say that if you want to do all these loadings, actually there's interface. So you can import data sets. So you can just go to like File, Import Data Set, and from SPSS. And basically what this thing will do is do exactly what it is that I'm doing over here. It will even like help you through the process. So which file do you want to do? And it will give you the code. So I'm showing you a code just because I did this already, but if you want to do this simpler, you have an interface. It's as easy as SPSS in the sense that you have clicks that you can go through here. So File, Import Dataset, and you can import dataset from whatever it is that you used before. It's that easy right now in R to load the datasets. And then you're thinking, okay, I loaded datasets, but now I'm really scared because I don't know what else I can do. So now I want to tell you that R has come a long way in the sense that it has some interface. So I'm just like going to show you what is R Commander. And if you don't want to mess around with the syntax, you want to get used to it a little bit more first, you can just open this library. So it's called R Commander. And the nice thing about this R Commander is that it looks a little bit like SPSS. So it has all these things that you're familiar with in the sense that the statistics, summaries, everything. Like the only thing is that you need to do is that you need to set the data set. So I'm going to set the data set to this tooth growth. Okay, so I've loaded the data set. You can see over here it tells me the data set tooth growth has 60. So till now, we opened the data set through the file import, so it's in there. And then I am just like opening this R Commander that looks like SPSS. But the nice thing about this, unlike SPSS, is that it automatically gives you the R syntax, and it also gives you automatically something called R Markdown. So once we said, okay, let's use this tooth growth over here, we can actually edit this data set. So as you can see, this is like a familiar interface, and you can just like go in one of these. I strongly recommend you don't, because that's not good for reproducibility. But let's say that you wanted to just play a little bit, you can do that. So you can just like open the data sets from here and then edit this in all sorts of different ways. If you just want to view it, you can view it. It's not like the nicest way, but at least it will give you like something over here on the right side. Now, let's say that you want like some summaries of all sorts of things, then you can like have a summary of everything in this data set. So it will give you, for example, the length. So over here, the output of R Commander is back on the console over here on the left. So it gives you the mean, and it gives you like how many are in each condition and so forth. So already, just like by going here and doing summaries, you get stuff in R to you know, all the things that you wanted to do just by point and click. If you want to do, I don't know, some other things. So for example, let's say that we want to do a one-way ANOVA. So it basically tells you, okay, so you have some groups and you have a response variable. I'll just tell you that this is the one, and then say I want to do a pairwise comparison and some Welsh t-test, and just run OK. And you can see it gives me all the code, and it runs it already to give me something like an ANOVA interface. So it runs everything that I need, and it gives me sort of like a conclusion, even with the p-value over here in terms of the F statistics, the degrees of freedom, and the p-value. So I have all of this over here built in, and also has a bunch of things that I can later adapt. So I can copy paste this. This is the code, and put this in my R. So I can just like open this over here and then just put my code over here, and then it's all good. If you also want to load other data sets, let's say that you don't want to do this from RStudio, you can just like go here, load a data set, import data from whatever. If you even have other stuff, you can play with this. It also helps you how to load the packages. It also does some graphs. So there's a bunch of things that you can do over here. Let's see, I want to do a box plot. So I want to do length, but I want to plot it by group. So I'm going to group it over here, and I'm going to run this. So already immediately it opens up this sort of thing over here on the right. So that's a little bit simpler, I think, than what we assumed it's going to be to run this sort of thing. Now, what is this R Markdown? So all the commands that I just ran right now, it already gives me this in a reproducible way. What makes this reproducible? It makes it reproducible in the sense that all the code that I ran is under these sort of chunks of code, but in between I can enter some text. So I can enter text here, and then enter some text, text 2 here. And finally, I can generate a report. And if I generate this report, it asks me, what do you want? Do you want a PDF, a docx, whatever it is that you want? So I said, oh, I want a PDF. And you can see that over here, it's working hard, and it's trying to produce my PDF for me. Just gonna, yeah. So it opened the PDF, and here's my PDF. So you can see it entered some text here and another text here. It showed me the code that I used, but it also showed me the output. So right now, everything is reproducible together in one place where you have your text, it has the code that you ran, and then it has the output together. You ran an ANOVA, it gives you the ANOVA. You ran, statistics and even your plots, it's already here, and this is a PDF. You can also export this to a docx and then just like use it in your own manuscript. So R Markdown allows you to combine code, output, and your own text. And your own text can just be, your manuscript. So you can build a manuscript from R Markdown. So this R commander, if you're afraid of R and you just want to get to know R a little bit better, or you want to simplify, automate some stuff, a million things that you can do with this. There's also other packages that you can load into R Commander. So it's like a very powerful tool for you to get started. So I'm going to exit this. I'm not going to save any of these things. So that's nice. So already we saw that we don't need to be that scared of R, because so far everything that we needed to load the data set and to run the most basic things from descriptives, editing the data set, viewing the data set, doing the descriptives, and outputting everything to a docx and a PDF can be done with a few clicks of the mouse within R. And all of this you can run with RStudio or R. It's up to you. Another package that I wanted to show you, just in terms of like how easy it is to plot stuff. So for example, this library over here. So if you install this, it actually will add some stuff to your RStudio. So you see this one over here, the add-ins over here on the top. Every time you install packages that support RStudio, it adds some stuff in here. This one, for example, the ASQUISSE, so that's the name of this package over here. So if you go over here, you see it has something called a ggplot2 builder. Now, ggplot2 is the most common way to plot stuff on R, but if we go on this ggplot, you'll see that actually says, okay, so which data set do you want to work with? And I want to work with tooth growth. So I'm just going to open tooth growth over here. I'm going to say that this is numericals. I'm going to coerce this, and I'm going to import this. So now I have these three variables. I'm going to put one as like the already, as I dragged and dropped over here, automatically it created this histogram for me. But then I can group those into different things. So for example, I can try and group this. Like I can add this over here. So already it creates this plot for me. I can also try and do some like click this in facets. So I can do a 2x3 kind of plot, and then you can see in terms of each one of these conditions, condition 0.5, condition 1, condition 2, plotting these two next to each other. So the only thing I needed to do in order to create this ggplot2, people say, no, ggplot is like a very difficult syntax. How do we do this? It's very, very complicated. Here I showed you this amazing package that the only thing that you need to do is install this once, and then every time that you go into your add-in, it's going to be there. And then you want the ggplot code, it's here. Now you can just insert this in your script, and then it's all ready for you. You can download the plot into a PPTX or your PowerPoint or a PNG. So that makes life easier, doesn't it? So suddenly, you see, it just inserted this thing over here for me. So it loads the package, and then it gives me the plot that I just showed you. And it has very complicated plots that you can do. Everything with clicks. Now, another package, I think that's one of the last ones that I want to show you about R, and then we're going to wrap R and go into JAMOVI, is that one of the most powerful ones, I really, really like this project, is ggstatsplot. It changed the way that I do statistics. I want you to just look at this line of code. You can copy and paste this line of code into your own syntax. The only thing that you need to maybe understand is that this is for running a between design. So in a nova of a between design, where we have, this is the data set. So tooth growth is once again our data set. You have the X and you have the Y. So the independent variable and the dependent variable. I'm going to use those and length. And the only thing I'm just going to stand on this, and then I'm going to run this. I'm going to show you what happens. So you can see over here that over here on the right, we have something called plots. So the code that I ran over here shows over here. I'm just going to zoom into it. So just, you see how wonderful this plot here. So just this very basic line of code telling it, OK, so this is my data set. This is the independent variable, the dependent variable, and it's called tooth growth. Just look at what this thing gives you with a single line of code. So it gives you this jitter dot violin plots, where it compares all the different sets of the conditions, the 0.5, the 1, the 2, but it gives you much more because it already runs the ANOVA. It gives you the p-value. It gives you the effect size with the confidence intervals and the number of observations that you can see in each one of those, where it gives you in each condition, this is 20, this is 20, this is 20, plus it gives you this base factor that you can, if you want to quantify the support for the null, then based on some assumptions, it already gives you some output about Bayesian. So just amazing in the sense that one line of code with very little information in it gives you such powerful plots that you can just basically go over here. You can export this, save this in whatever way that you want, and then put this in your manuscript. So it's very, very powerful. Another one I'm going to show you, so this is GG within subject design stats. Over here, once again, it has all sorts of things. This is a little bit more complicated. I'm just going to show you what this looks like. So I'm just going to run this over here. Oh, I didn't load the wine package. Where is the wine package? It's this one. So this one is the wine package, and then I'm going to load it, and then I'm going to run it. So the one package is included in this package over here, in this library over here. And what you can see is that in a within design, it really gives you all the required statistics for this one. Another thing that it does is that I added something very simple like pairwise comparisons over here. And what you can see over here is that it gives me the p-value between each one of these conditions. So the p-value between those is 0.02. It gives you, of course, the mean, between each one of those. It gives me the base factor, and it says, how did you run the pairwise comparisons using a student t-test, and what kind of adjustments did you do to the multiple comparisons? You ran the home. So one line of code, a few tweaks. It's a copy paste that you can do from the website with a lot of examples, and then it gives you everything in one plot. That is the power of R. So almost everything that you want to do, any kind of statistical analysis, any kind of plotting, if you want to combine this all together, anything that you want to do, there's an ability to probably do this within very simple lines of code. I won't lie to you, sometimes things go wrong. So sometimes, at the beginning, there's all these frustrating things about you didn't load the right package, or the package doesn't support with this kind of version. There's all sorts of things that you run into. But I think after you go through a few of these, you already know how to debug these things, and things become a lot easier. Also, R is not what it used to be 2-3 years ago. When I started doing R, I ran into endless issues, and then it took me a while to kind of debug everything. The nice thing about R is it has one of the most powerful online communities. So whatever your error is, you can Google this on Google Scholar, and immediately you'll find a solution. Or if you post what it is that you got, immediately, I would say within half an hour, you're going to get a reply. Sometimes not just one reply, a lot of replies with people trying to help you. So the power of open science, open source, of helping one another, there's a solution for everything. So when you make everything open, everything is much, much easier. Now, the advantage of having this kind of code is that once I'm happy with this, I'm just like, I save this, and then when I submit my manuscript, I include this code. I can also include the R Markdown, like the PDF that I just showed you, with some exportation of all the things in there. I think it's the way that science should be, and I think we're going in this way. So most of the things that I now review come with some open data. I refuse to review anything that doesn't have open data, but when they come, they usually come with R or with JAMOVI. So increasingly, more and more people are moving towards R. So I just wanted to give you a glimpse of what R is. If you were scared of R before, I hope that I kind of got you to rethink what this means in terms of the investment needed. Not too much. Everything is like very simple. RStudio really makes everything a lot more approachable. But also all these different packages about, Haven, that you can just like import data sets from over here, or the other things like the R commander, or this one over here, Esquisys, and also the wonderful GG StatsPlot. Now, we'll see GG StatsPlot again soon, because recently JAMOVI also included this built in within JAMOVI. So that's a powerful thing. So I'm going to ask you now, before I move on, if you have any questions. Let's see if there's something on the chat. Yes, so yeah, if you want to use R, first you need to download R and then install that, and then you download RStudio and you install that. And then the question is this going to be on YouTube? Yes, this and everything else that I do remote or this semester is going to be on YouTube. So everything is recorded. So if you want to go back and look into this, you'll be able to, no worries. So if you need to leave at some point, or you join us late, everything that I'm going to do, everything is posted and shared, all the presentations, all the cloud folder. So don't worry about this. You'll be able to go back and have a look and trace what it is that I've done. So if I'm going too fast, don't worry about it. You'll be able to come back to this. So I'm going to stop with R right now. If you have any questions, then please write this like within the next minute or so. Where do I find the files with the codes command? Okay, so I don't know when you joined, but at the beginning I had these things over here where I said there's a cloud folder. So there's a cloud folder over here that you can download, or you can scan over this barcode over here. So it's mgto.org JAMOVI workshop folder. Once you download this thing into your own computer, you'll see that this is the folder that you get. And then in this folder that you get, there's this directory called RMagic, and within RMagic, there's this Gilad's RMagic workshop. You can already see that the PDF that we did from R Commander is already here with your R Markdown code that you can use. Can we use R Commander to run SCM? There might be a package in there to run SCM, but I would actually recommend for you to hold off with that, because I'm going to show you a much easier interface for you to write to do SCM within JAMOVI and JASP, or at least JASP has a much simpler one to do SCM. So R Commander doesn't allow you to do that simply, but JASP is a little bit better with this and some of the things in JAMOVI. Anything else? Okay, so I think that's about it for this one. Since we're already talking about the folder, I'll just remind you that this presentation is here, so you can have a look at this. Now I'm going to ask you for a little bit of feedback, because I want to know who you are. Oh, and please mute your microphones so we don't have any interruptions. Let me see. Study Mentimeter. So I'm gonna open this. I'm gonna ask you a few questions. If you can go on the Mentimeter, please. I'll just show you what that looks like. Hold on. Okay, so I'm gonna present this to you. So you can see the Menti if you go to menti.com and then input this code over here, 251041.6. I want to ask you what statistics software you most frequently use. You can choose more than one. So like if you have Excel, SPSS, SAS, if you've used more than one, then please do that. If you can't access this, okay, I can see responses now, so that's good. So this will kind of give me a general idea of who you are, and then I'll know what to focus on. Okay, so some of you have already used RStudio. I don't know if what I showed you right now is new to you, but I think you already know, if you've used RStudio, that R has some wonderful things in it. Some of you have already used JAMOVI, so that's good. I hope that I will be able to show some new stuff to you. But it's I can see like the majority over here are using Excel and SPSS. Some of you are using Python, MATLAB, so that's good to know. Thanks for that. I appreciate this. So like we have around 50 voters over here. Good. Okay, so it's good for me to know that many of you have been using SPSS, but you also have some knowledge. So I would ask the group over here with the RStudio and JAMOVI is like, if you have questions that are a little bit more advanced, you can try and write this in the chat. And then if it's relevant, and I think it will also be helpful for the others that have less experience, then I will also try and address that. Okay, let's move on to the next one. When you use, let's say, SPSS or the other stuff, do you use code or syntax? Some people don't know what that is, and that's completely fine. I just need to know if you've used code or syntax. So to me, one of the amazing things about SPSS is that it seems like a lot of people have been using SPSS without syntax. So basically, every time that they run their code, every time, again and again, they go on the, the dialog boxes and they do the same kind of clicks. The reason not to do dialog boxes but keep everything in syntax is for you to document what it is that you're doing, so that you'll be able to come back to it later on. So if you put everything in a syntax, it's much clearer to others what it is that you just ran, and then they can run it similar to you. So SPSS has this option of paste, where it pastes the syntax. I don't know why, but in some places where I go, some people still don't use syntax. Now, the nice thing about JAMOVI is that JAMOVI uses syntax, but it hides it from you so that you don't have to bother with it. So it includes the syntax, but it's kind of like in the background doing stuff for you. So JAMOVI kind of like brings in the good of both worlds, in the sense that you can focus on what you want with the click dialog boxes and all that, but it has the power of the syntax inside it. And I'll explain a little bit more in detail later on what is code syntax in the sense of JAMOVI. But at least in R, I want to say that this over here is our code. This is what we run, and we can run this step by step. This over here is our output and our plots over here. So we need this code. Let's say you want to follow what it is that I'm doing. You can go and punch in your your command, or you can go to R Commander and open your stuff. But let's say that you want to follow exactly what it is that I'm doing, step by step, one command after the other. The only way to do this is that if you have my R file, and then you can just say, okay, first I download, I install the packages, then I load them, then I set the working directory, then I play a little bit with Swirl, then I load all my SPSS. So this way, you know what comes before the other, and you can run exactly the same thing without having to second guess. So it's not just you sharing with other people. Let's say 5 years from now, I want to go back and see what did I do with the participants of the workshops in JAMOVI in 2020. It's going to be very difficult for me watching the YouTube video and following everything together. It's much easier for me to just like open the R code and then see, okay, so this is what I've done, and then I can run the same things. Obviously, there's some other things about reproducing this. So there's some versioning, and in 5 years, RStudio is going to be very different. But we also have ways to not only keep the code, but also keep sort of like the environment around it. But that's a little bit for later. Okay, so thanks for sharing this with me. I appreciate that very much. Next one, I just want to know if you have any. So some of you indicated you've worked with JAMOVI, but I want to know if you've used anything for your research projects, like hands-on. Do you have any experience with such things? Use JAMOVI for a research project. So that's great. So many of you have some experiences, but okay, increasingly never used any of those, so at least 14 of them. Okay, good. Okay, so that's helpful. Thank you for that. Yeah, so some of you do have, like about 16 of you have some experience with JAMOVI. That's good. And then R, wonderful. Okay, so I'll try and appeal to these three. I like it that 4 of you have tried JASP. That's terrific. I'm going to touch on JASP quite briefly because I think it's quite similar to JAMOVI, but it does have some perks in terms of things that it adds beyond JAMOVI. Okay, one more question that I feel is important. What designs do you most frequently use in your research? So it's more like correlational designs or experimental? Do you do more between or within? Do you do mixed? Like what is it that you do? And you can choose more than one. Okay, so it's pretty balanced, it looks. It's like there's not one specific thing. Okay, I get it. Okay, so we'll do a little bit of everything, I guess. Okay, very balanced. Got it. Okay, good. So I think we're done with this survey. Thank you very much for participating. I think we're ready to kind of dive in and look a little bit more into JAMOVI. I'm gonna close some stuff because otherwise my computer is going to give me some problems. Can already feel it working in the background, like heavy workload. Okay, I think Chrome is the #1 issue. All right, so what does JAMOVI actually look like? Let's open JAMOVI over here. The latest version, which I think is a very big improvement in terms of all sorts of things, is 1.6.3. If you have previous versions, I really recommend that you try and upgrade this. All right, so let me just see in the chat. Yep, good. Thanks. Okay, so if you've downloaded JAMOVI and this is like your first time opening it, you might have a little bit less than I do. So it typically starts, I think, with these 4 or 5, yeah? And then all these things over here are stuff that I added. So I'm going to show you how to add some stuff. Let's say that you want to have a JAMOVI as powerful as mine. So you'll go over here, you see this plus sign. It says modules. If you press on these modules, there's this thing called JAMOVI library. And the nice thing about JAMOVI is that it's possible to extend the JAMOVI in all sorts of different ways. So all these modules that you see over there in the back are modules that I've installed. You can see all my installed things are over here. So for example, I installed things like FlexPlot, or a JJ StatsPlot, which is a wrapper for GG StatsPlot. So all these things are, people added some stuff on top of JAMOVI in order to increase its functionality. So I'll be going over some of these more advanced things a little bit later. Now, the thing I want to tell you about JAMOVI is that JAMOVI runs on R. So everything under the hood for JAMOVI is R related. So not almost everything that you run on R, you can see what the syntax is for JAMOVI. So we'll start with something fairly simple. We'll go and we'll load some of the pre-existing data sets that are in here. Let me just like close this thing over here. Yeah, okay. So you'll see over here that there's this open and this PC if you want to open something from your PC, or you have a data library. So if you go into this data library, you'll see that you have a bunch of things. Do you remember this tooth growth? So tooth growth is going to keep coming back and haunt us. The reason is because it's a very popular data set, freely available, uninspiring ANOVA data set to demonstrate ANOVAs. So let's open this and play a little bit in order to understand what happens with this data set. So as you can see, I didn't explain this very well when we were in RStudio. I'll explain this a little bit more in depth right now. Over here we have LEN. Now, if we double click on LEN, you'll see that this interface over here on the top opens up. And you'll see a bunch of things about it. So for example, you'll see that in terms of measure type, it has this ruler. So you see this ruler over here. And then it says continuous. But we have a bunch of other types of variables. So you have nominal and ordinal, or just an ID. You can also change if it's a continuous. Is it integer or decimal, or is it just like text? And you can also set the missing values. So if it's NA or if it's anything else, you can set this over here and add some missing values to it. Now, we'll close this and we'll have a look at this sup. So sup thing has 2 levels. So we can see that some of the participants over here have VC, and some of them have OJ. And finally, we'll look at this dosage thing, dose. So some of them receive the 500, some of them receive the 1,000, some of them receive the 2,000. So here we have 3 levels, where this is 2 levels. So that really allows us to demonstrate a very nice ANOVA with a 2 by 3. So let's say I open up this thing. So this looks a little bit familiar from SPSS and some other things. So it's like I just did a bunch of clicks and this opened it up on the left. I urge you not to do this, but you can actually go and edit this if you just like double click on the actual thing, each one of these, and then manually edit these. So this is like one of the a very easy interface that you can play around with. I'm going to go ahead and just do a very quick exploration. So let's look at this descriptives over here. So I click on exploration and go to descriptives, and immediately it opens up this this interface. You'll see this looks just like SPSS. I think it's on what's this question? JAMOVI, how do you recode? Yeah, I'm going to show you how to recode and how to compute everything. I'm just going to demonstrate descriptives first. I just want to give you like a sense of how JAMOVI works. So we have this continuous variable, and this is our DV. So we're going to just like put this over here. Now, what you can see is I just I just drag this from here to here, but look what happens over here on the results. So in, let's say, SPSS, you need to run things first. Here, everything is dynamically updated. So I just drag this over here, and immediately it gives me the results over here. Now, I can split this by one of the factors, and then it gives me, for each one of these conditions, the OJ and the VC, what the N is and what the mean is and what the median. So that's nice. I can also split this by two variables, and then it will give me this whole table over here. What's nice about JAMOVI is that if you look at this and you think about this, this is an APA-style submission-ready table. So you can just take this as is and put this in your manuscript. Don't know what it is that you used before, but SPSS is horrific this way. There's a lot of copy pastes and things that are very bad in terms of like getting things wrong. It's not as nicely put in here. But if you just like, let's say that we open Word and we just want to put this in our, we can just like do a right click over here, and we can do copy or export. We can copy this into the clipboard and then just like go over here and paste this immediately. So very easy, almost everything that you want, you can, and then you can edit this within your Word. So very easy to do stuff over here, and everything is dynamically updated as you go. Now, with a bunch of clicks that I'm going to do, you'll see that everything updates underneath. So first of all, you can add a bunch of things, and this is like the common stuff for a descriptive. So you can add the standard deviation, and immediately it adds this dynamically over here on the right. It also has some really nice plotting stuff. So I showed you a little bit with R and the R commander, but let's say that I want this jitter dot violin box plots. So just by doing these 3 clicks, it takes a little bit of time for it to compute, but finally, over here will give me a really nice plot that I can take just as is, and then just like copy this and put this into my manuscript. So that's nice. With very little effort, we get these really nice plots. So that's sort of like a really nice introduction to this whole thing. Let's just like take a little bit of this out. You don't need all this stuff. Now, I want to show you, now that we have this like basic understanding, okay, so we can run descriptive with a few clicks, and now we have these over here. It's also possible for us to edit. So this is one of the things that was introduced in the latest version in JAMOVI, that you can go over here and you can edit some of the descriptives and add some stuff about the results if you want to like add some description to it. So then you can you can just like add a note. This is my note. Great table. So a bunch of things that you can do, and then just like embed this over here within your plots in order to do better reproducibility. So that's really nice. You have all these plots, but you can also add some notes on the top. So you can like add stuff over here, add stuff on the top. So that's really important. So if you keep these files and you save them in your computer, it has everything in it. It has both this over here on the left. So this is the data. It has the outputs. It has your notes in it, and it has the analysis built in. So just by me clicking, it gives me what was the analysis that led to it. So if you think about SPSS, SPSS has, on one side, it has your data, .sav. On the other side, it has your point-click output and stuff that goes, I think it's .spv or something like that. I haven't used that for a while, but an output file. And then you have a syntax file, and these 3 are disconnected. If you're missing one of those, maybe you don't see the entire workflow. But the nice thing about JAMOVI is that JAMOVI puts everything together. Some questions? Sometimes the automatic dynamic slows things down. It definitely does, which is why you would want to keep the stuff lean. So if you have a very, very long JAMOVI file, if you change even one thing in a variable, it's going to take a very long time for it to compute. This is solved to some extent with JASP, but JAMOVI, this is the way that it works. So I agree that dynamic automatic update of the results has advantages, but definitely has disadvantages, especially as you've seen my computer, especially if it has a bunch of stuff going on in the background. So all the cloud folder updates and the stuff that's running behind really increases the load to the extent that if I do too much on JAMOVI, my Zoom crashes. So that's yeah, I agree. There's some good and bad in this dynamic loading sort of thing. But I want you to understand, like, why is this so heavy? One of the reasons why it's so heavy is because JAMOVI not only loads this really nice interface, it loads all the R underneath in order to run everything that you want in there. Now, if we understood this descriptives ones, and this is a really easy way for you to just get to know the JAMOVI interface. I'll show you some more complicated stuff afterwards. But what I want to show you, so if you look over here, do you see the top right side? There's next to the plus models, there's also this 3 dots that you can almost miss. I don't know why it's so hidden over there. But you can do all sorts of things. Of course, you can zoom in. And you can change like the p-value. Do you want it 3 points like APA style, or perhaps you come from a different discipline and you want 5 or anything else? You can change this. I don't know if you noticed, but over here, if you want to cite the wonderful people in JAMOVI or the R core team, I would strongly urge you to cite these in your manuscripts. We try and do this at least in the supplementary, if not in the main article. But you have these reference over here, which is you can just copy paste. But let's say this is annoying for you for some way. I don't know why. You can hide this. Another reason to include this in your output is that it tells you which version you're working with and when this is happening. So for example, here, the R version that's used and so forth. So you can go over here. Now, the one thing that I really wanted to show you over here is this syntax mode. What happens when I click this over here? So if you look at the output, what happens is that actually this is an R code. What it does is it uses this package called JMV, and it runs this function. So basically, the only thing that JAMOVI really does is it gives you a really nice interface for an R code. So I can actually go here, and I can copy this syntax. I can go on R and place it over there. As long as I've loaded the JMV package, I can run this code. So I loaded the tooth growth. You can see all the formula, all the data, and all this, and everything from that moment on, I can just run this on R. The only thing that I need to take care is that it assumes that my data set is called data. So tooth growth needs to be loaded into this data over here. But the nice thing is that everything that you do in JAMOVI is very easily translated into R syntax. So let's say that you want to get to R, but you're not sure how to get there and it's really scary for you. You can start with JAMOVI, but every time you do something, rather than just like keep it in JAMOVI, you can just like copy paste and put this back into your RStudio. Is there a module for propensity score matching? I'm honestly not really sure. Does higher computing power solve this speed problem? Somebody asked. Definitely. Well, my computer is like 3 years old now, so it's not catching up. And I think JAMOVI keeps adding some stuff, and every model that comes in and every R update, things get a bit more hectic. So obviously, if you have a more powerful machine, things are gonna work better. But generally, I have not come to the problem. Maybe in some SEM stuff like conformatory factor analysis, and maybe in some of those I had to wait. I don't know, like 30 seconds once, but it doesn't come to the point where you have to wait the whole night. There's nothing I think in here that would require you to wait that long. And generally, I would urge you to split your JAMOVI files into manageable bulks of code, or just use JAMOVI as like a baseline to move into R, and then in R there's no issue. You just run the code that you want to run. But this is really the main thing that I wanted to show you. Underneath JAMOVI is R. So you can use that in order to transition. And everything is over here in this very well hidden 3 dots of syntax mode. Another thing that it has over here is that you can do the plot theme. So I don't know, let's say you love SPSS. For some reason, you can change the plot theme to look like SPSS. Why would anybody do this? It's horrific, but fine. It's a feature that you have in here. So that takes care of like the basics of JAMOVI. So hopefully that got you thinking about this. The other thing I want to show you, why is JAMOVI so important? I'm going to show you like one of the things, perhaps with moderation mediation. So I'm going to show you a moderation mediation capability, but it's not about moderation mediation right now. What I wanted to show you is that the JAMOVI files are saved with this .omv ending. So if I go, for example, over here, and let's say, where am I going to save this? Let's say I'm going to save this to the main directory of the JAMOVI workshop. So I go over here, I save as, I browse, and I go into like the main one. I'm going to save this as toothgrowth.omv. And there's a reason why I want you to see that. So it saved it, and it's over here. But the thing about this toothgrowth.omv, first of all, it's one file. So you don't have .sav, .sps, .spv. So you don't have 3 different files. Everything is in here. So you can just send this one file to your collaborator, or one file put in the cloud folder, or one file upload to your open science framework. And this is the only thing that anybody would need in order to reproduce your results. Now, let's say your collaborator does not have JAMOVI, and they still want to read this file. Now, this file is just an archive. It's a zip file. So you can load this zip file. You can go over here and open this archive, and you'll see that inside this zip file that's only called OMV, actually it includes everything. So it includes, the descriptives that we just ran. It includes this in here. And another thing is that everything that's loaded is loaded with images and HTML files. So let's say 10 years from now, somebody tries to reproduce your code, but there's no JAMOVI anymore. For some reason, they finished funding, something doesn't work. The only thing that they have is this OMV file. How are they going to load this? So the way that they load this is that this is an archive file, this zip standard, everything, it opens it. I use this, I don't know, this 7Z thing, or you can use whatever other software. Windows handle this, I think Apple handles this. And inside, you'll just see that this is a regular PNG, transparent PNG, which is why in my dark mode, it looks dark. But you can just open this as a regular archive and then just like look at all these. So if I just like open this HTML, it will load this sort of thing. Now okay, so we've seen the .omv files are just archive files that include everything within it. So this OMV file is the only thing that you need in order to share stuff with your collaborators or share things with the world. Okay, hope you had a good break. Every time I restart, I lose the chat room. So if you asked a question and I didn't see it and you want some answers, this is a good time to ask while people are coming back from the break. If there's something that you want me to, it's a dynamic way to reconstruct the descriptors table, like having all the descriptors ordered by variables. I think it's up to you how you want to, like the order that you want to keep this, like unless I'm misunderstanding everything. It's like it's up to you how you want to do this. And also I think in terms of within the variables themselves, I think it's the order. So I think the lower ones come after the, yeah, so you see OJ here and VC here. So OJ comes first and the VC comes later. So it's just the way that you structure the levels, and I think you can just like shift them. And this, yeah, of course. Go ahead.
Oh, hi, Philly. This is
Hi.
Jessica. Yes,
Yeah, hi,
actually, my
Jessica.
question is, if you look at the table down there, so now you will see that all the statistics about order, like first it's n, the cell sizes, and then
Oh, this the end, the missing the standard
right, right,
deviation.
right,
Ah,
right.
no, I
You
think
want to have yeah, all this.
that's fixed. I think that's fixed in here. I don't think you can do much about this.
See.
But there's some other ways of doing summaries which I didn't go into. So you can go over here. There's a bunch of other ways for you to describe your variables, and perhaps one of these will be better. I'll show you one other example that I was going to show just now on how to do the descriptives, which is part of the ANOVA. And hopefully that will look a little bit more like what you expect, I think, in a manuscript. So let's
Right.
just hold on with this. I'll show, but there are some other options. But of course, it gives you what it gives you. If you really want to edit this and play around with it, you'll need to kind of take the syntax, the R syntax, move to R, and then play around. But there's typically more than one package that allows you to play around with this. But at least this descriptives is, I think this one is fixed, unless I missed something. Yeah, I don't think it's in there. I think maybe one of the things that you can do is kind of like take this one by one, and then just like copy this and then copy that. But it's like because this is Word, you can also, of course, go around and copy this to your Word and then play around with Word. So you can do this in many different ways. But at least in this interface, it's a little bit limited. So either use a different package, export this to R and play through R, or export this to Word and then just edit things in Word the way that you would like to. And I think Word is maybe the easiest for you if you just want this for your manuscript. But let me just show you a different way of doing this. So let's say, for example, I want to run an ANOVA. So you'll see already that the nice thing about JAMOVI is that it gives you a few options for an ANOVA. First of all, it of course has all the ANOVA, repeated measures ANOVA, ANCOVA, MANCOVA. So you've got a bunch of options in terms of what is your design. If you have a continuous and a categorical, then ANCOVA. If you have 2D-Vs, MANCOVA, you have a bunch of things to do. But another thing that you can see this Bayesian over here. So I added this module called JSQ from this model over here on the right. So you can actually also run a Bayesian ANOVA if you're more of a Bayesian analysis sort of type. Let's start with like a regular ANOVA. What does an ANOVA look like in JAMOVI? It looks something like this. So it comes clear, and then we'll just drag the dependent variable over here, and we'll add our fixed factors. And already, of course, it loads things dynamically, so you can see at least you have your f value and you have your p value. And this was done fairly quickly because we want effect sizes. You can add your partial and regular eta square. So you have a bunch of things that you can do this. And of course, if you want the model fit of the overall one, you can add this. But here with one factor, it doesn't do much. But if we add another factor, perhaps it's a little bit more meaningful. So you can add both factors, and immediately you can see it also gives you sort of like the interaction between these two. So at least with this sort of model, you can see that each one of these factors in terms of the p-values is significant, but there's a very big difference, at least in effect size. So the dosage thing seems to be a much stronger effect. The f-value and the effect size are different. So already it gives you a bunch of things. And in terms of the interaction, you can already see the interaction. So like a few clicks, just like SPSS automatically. But it's also more powerful than this. So you can already add a bunch of stuff in there. You can check some assumptions. So is this really a normal distribution? So already immediately it brings up all these normality tests, very easy. To look at that, you can do some contrast. You can also do some post hoc tests. So for example, if I drag all these things together, so let's say I want to know, because I can see the dosage has three conditions. So I want to compare between each one of these three conditions. First of all, I have a main effect. So these are my three conditions. So 500 versus 1,000, 500 versus 2,000, 1,000 versus 2,000. And it gives me everything with the p-value corrected for multiple comparisons. So you can decide if you want this like the 2 key or some other things. Another thing that's increasingly required in APA journals, definitely the top ones, is that you need to report the effect size. So here on the top, we had the entire effect size for the ANOVA model. But let's say that you also want the effect sizes for these post hoc comparisons. You can just add the Cohen's d and the confidence intervals. So that's really useful. And already it adds everything over here on the right. So doing this thing in SPSS is a nightmare. It's just like, first of all, just like doing Cohen's d in general, not just for an ANOVA, is a nightmare. But over here, you can see it gives you this for each one of the main effects, but it also gives you this thing for all the possible things for the interaction of these two factors. And all this within a few simple clicks, and with all the corrections that you want. You can also add more than one correction if you want to it. So you have Ferroni next to the two keys. So you can like do a bunch of things in here in order to get to what it is that you want to do. But if you want like a different type of plotting, you can like drag these things over here. Sorry. Yeah, I'll just show you, for example, the plots that this gives outside. So you can see this kind of plot, or if you prefer this kind of plot. So just by dragging this estimated marginal means, I can get this. So it's like a different type of plot. So up here, we had this jitter dot basic thing with descriptives. Over here, we have slightly different things with, the confidence intervals and all of that. Yeah, some of the observed. So it's like a different ways of looking at all these things. Anything else I wanted to show you over here? Yeah, let me just see if there's something in the other ANOVA that I can show you. This is okay, yeah, I wanted to show you the other descriptives. Okay, good. So let's say that I have this like grouping variable, and I want to do this grouping variable. So this one doesn't allow you more than one factor, but I want a descriptives table. So this gives me a slightly different way of looking at this. So here you can see it's columns rather than rows. So it's like a different way of looking at these things, and also another way of plotting this if you want this plot. So you've got two types of ANOVAs. I think this is the simplest one, where you just have like a one-way. If you need a two-way ANOVA with two factors, you can just like use the second ANOVA. But this already gives you a little bit, another way of doing this descriptives plot for doing a main effect for an ANOVA for each one of these conditions. So 500, 1,000, 2,000 post hoc. Yeah, report the significance. Like you can do like a bunch of stuff over here in terms of like with the post hoc effects in what looks like a correlations table a little bit. So hopefully that helps wrap up at least the ANOVA. The simplest version of two conditions ANOVA is a t-test, or you can also have a t-test. So if you go over here and you do a simple t-test, very, very simple for you to run. So we have one factor that has only two conditions. So you can see what happens when I compare these two conditions, and you can already have the effect sizes and the confidence intervals for both the main effect and so the raw mean difference and the standardized mean difference for the effect size Cohen's d. You can also do descriptives and descriptives plot. So once again, you can get this in another way of looking at these things, and also this familiar plot. You can also add the Bayes factor if you want Bayes, or if you prefer to do the Welch t-test instead of the student t-test. So that's so a lot of things that you can do in this very simplified design, two conditions so far. Looks like you always have to start with the descriptives, then run the ANOVA. Yeah, so actually in the ANOVA, there's a way for you to just flag that you can add the descriptives or the plot, so you can just like have a general look at this. But yeah, generally I think that one of the first steps that you always want to do is just like have a good look at your descriptives. But there's also some of the things in the interface that allow you to do this in ANOVA. But like you see, there's some differences. There's some good and bad in it. Let me see if there's anything interesting over here to show you in the other kind of descriptives. I can't remember what these ones do. So let's look at all these variables and see. Yeah, you can only do these kinds of variables. Yeah, so it gives you like a mean and a median and a minimum maximum. So if you want to explore a little bit, there's a bunch of other things that you can do. And the nice thing, of course, is that you can copy this into your manuscript immediately and do some stuff with that. What's a variable tree? I can't remember. I think this is one of the newer ones, but oh yeah, okay. That really gives you um, a bunch of things to explore in terms of like the different factors within each one of those. So how many people do I have in each condition, and each condition how many I have of the other factor. So it's like a nice way to look at the variable tree in order to kind of like understand what your data is. So there's a bunch of stuff that you can play with over here. All right, let me see. Yeah, okay. What else do I want to show you over here? Yeah. So if you liked the GG stats plot that we had from R, and you're thinking, oh my God, I want one figure to have everything. So I want the effect size and the statistics to be on the top, and then I want to see the jitter dot and all this. So you have ways to do nice graphs. Let's say that you don't know whether you have categorical or continuous. So you can choose to do like violin plots for independent samples. So for example, I can choose this independent sample over here, and I can put this over here and add this. Already you'll see that this has this like violin plot. It takes a little bit of time to load because it runs all this like R underneath, and then it loads the GG stats plot. But finally, it will give you this sort of thing. So actually, you don't need the sophisticated R code that I just showed you from before with the GG stats plot. It's built in JAMOVI right now. So these beautiful things you can actually take. If it's too ugly for you, I think there's a way of like making it a little bit nicer in terms of the fonts and all that. If you want this split, so you want this like 2x3 factor, a little bit more complicated. So I think this is close to the, oh, maybe it's better that I do it the other way. Hold on. I'm gonna do those over here and stop over here. I think that will look a little bit better and will be easier for it to compute. Yeah, so this looks better. Okay, so you can actually see for this is for OJ and this is for VC. So these two conditions, how the 500 and the 1,000 and 2,000 like compare between them. And then you can just like copy, paste, or export this and put this in your manuscript, and it already has everything. So it has the overall F, statistics and the effect size and everything else that's in there. But let's say that you don't remember, you can actually do graphs and plots, and then without you knowing exactly what's, is it continuous or is it categorical, or which one to do, you can just like start adding them. And as you start adding them, things will start showing up over here on the right. You can also add the grouping over here, and you can add the dosage. So little by little, as you add stuff, things get updated. So we have two kinds of modules, packages that do this. So GG StatsPlot is my favorite because within a single one, you can see all these comparisons together. Another one that we have is a really nice one. It's called FlexPlot. Very similar kind of idea. You can go into FlexPlot. So let's do FlexPlot over here. Over here as well, you don't really need to know much about is it continuous, is it so I can just like add the continuous variable. Just by adding this, I already have the distribution of this continuous variable. So how many counts I had in each one. So just like by dragging this over here, I already get some results. But every time I add a predictor, it updates the plot dynamically in order to show me something interesting. So just by adding this predictor, it now shows me these two figures. If I add another one, then it already does the 2x3 for me. So this is another way for me to plot things. So you can use FlexPlot, you can use GG StatsPlot, you can do all sorts of things, and you can also play in terms of the stuff that you want to show. You can also edit this, like how do you want your jitter plot, and so forth. I think, let me see if there's anything else I want to show you with this one. Oh, equivalence testing. I don't know if you're familiar with equivalence testing, but all of these ANOVA's t-tests, all of these traditional tests, basically what they try to do is they try to show that you're meaningfully, or what's called significantly, different from the null, so from zero. But sometimes when you think about this, let's say that you have a very large data set and you don't really care about the null. So let's say you have 60,000 observations. I work with the world values survey sometimes, and then almost everything that I run in there, because of the very large sample size, it comes out significant. So significant is not a good factor for examining how meaningful an effect size is. So increasingly, we try to shift away from p-values and this magic number of 0.05 and shift more towards examining things with effect sizes and confidence intervals. The good thing about using effect size and confidence intervals is that it gives you a little bit more information about where your effect size is and how accurate your estimate is. So generally, you can say that if your effect size and your confidence intervals do not overlap with the null, depending on what percent your confidence intervals are, then p-value is going to be lower than 0.05. However, sometimes you want to compare your effect to a different effect size. So let's say that you decide in your own analysis, I only care about effect sizes that are meaningfully different from Cohen's d of 0.2. So this is what equivalence testing does. So you can do an independent samples t-test, for example. We can run this as well over here. We can do this subgrouping variable. And then I can tell it, as you can see, lower equivalence bounds and upper equivalence bounds. And I can tell it, I don't only care about the null. I want to know, is it meaningfully different than Cohen's d of 0.5 or 0 or minus 0.5? And then it shows me a comparison, so a t-test not against the null, but against the effect size of 0.5. So as you can see over here, actually, when you look at the effect over here, the effect size is compared to the upper bound, so the 0.5 and minus 0.5, and then it does a p-value that gives me a comparison to that. So if we just run a t-test against the null, you can see it's pretty close to 0.05. So some people would say, hooray, we find something, maybe we can get this published, and all that. So equivalence testing still uses p-values, but in a much more meaningful way that allows you to compare effect sizes. So over here, you can define what is the meaningful, the effect size that I really care about, the effect size of interest that I want to focus on. So if you have, let's say, a pre-registration, you can say in advance, when I look at this data set and I do a t-test, I want to know whether the Cohen's d is meaningfully different than 0.2. You can also have this like descriptive statistics in order to, so that's another way of doing statistics and some plots. And basically what it tries to show you is like the upper bound and your lower bound, so where it is that you defined things to be and where your effect size is. So you have this for a one sample t-test, an dependency t-test, a correlation. So you can run this about all sorts of things. Increasingly, I see more and more of these equivalence testing because we try to understand whether we have an effect that is meaningful, not just significant in the p-value sense, but meaningful is that it's larger than an effect size that we previously identified to be important for us. Okay, I can't seem to find JASP stats in the JAMOVI. Is it a module? No, I think everything is available in all versions, but I think it's a module that is available for the later version. So just make sure that your JAMOVI is 1.6.3. And if you go over here, you should be able to see, where is it? Yeah, so ggstatsplot, a wrapper. So this should be in here. If you don't have it, it's very likely that you have an old version of JAMOVI. So you might want to update this. Actually, I don't know of any packages if they're in just Windows or some others. That's a good question. I actually don't know. You have the latest version and it still doesn't show up. Yeah, that's weird. Not really sure what to suggest. Maybe use a flex plot. So you see the flex plot, you see the other ones where you don't see the GG stats plot. So that's weird. Okay, so we've seen, so some of you indicated that you do experimental stuff. Some of you indicated that you do correlational stuff. So let's look at correlational stuff. So we're gonna close this for now, and we're gonna open a different kind of data set. The different data set is this thing over here called Big Five. I don't know if you're familiar with the personality traits of Big Five. So you've got, yeah, maybe I'll close this one. Yeah, just so my computer doesn't crash on me. Okay, so we have these columns over here, and they represent the Big Five. So it's a publicly available, open, unidentified data set. So you see these continuous variables over here. So you've got, let's say, I don't know, extroversion over here. So you see it's a continuous, it's a decimal. You can see all of these. Since somebody already asked me, I think this is a good time for me to show you how to do computation. So let's say I have this sort of thing, and I want to compute a new variable. So let's say I take this agreeableness. I can do a right click, and then I can add a variable. And if you look at this added variable over here, there's a bunch of things that I can do. One of them is a computed variable, and one of them is a transformed variable. So I'm just going to insert one over here. You can see I can call it whatever I want. But if I already know that I want to compute something based on one of these, I can say, for example, I want to focus on agreeableness. So immediately we'll call it agreeableness. You can call it like, I don't know, recorded or something like that. And then it says using transform. And you have a bunch of ways to do transformations. So let's say, for example, you want to do a very basic transformation of, I don't know, like log 10. So you can go over here and you can have a look at all the things that are available. And you can see that in the math functions over here, there's a log, oops, I need to do it this way. Yeah, so there's a log 10 over here. The only thing that you need to make sure is that you include the source within the function. So these are typical R functions that you can just add over here. You can also make this about more than just one variable. So you have all the variables that you want over here. It's up to you which ones you want to include, but this is like the simplest form of this. And you can see that what it does immediately is that it takes this and runs the logarithms. And you can use this transform. So for example, if you've already used this transformation, let's call it log 10. So let's say that you've used this transformation and you called it log 10, and you want to run exactly the same transformation on this one, you can do that as well. So you append this, you run this on conscientiousness, and because it's already here in the system, log 10, you can already run this log 10 and insert this, and it will say conscientiousness log 10. So if you want to transform a lot of variables and you want to do all sorts of things about it, then this is a good way to do this. Should I download JAMOVI Solid or Current? I don't remember which one is which, but just download the latest one, 1.6.3. That's the one that I'm showing this on. So this is transformation, and you can transform this in all sorts of different ways. You can do a bunch of complicated stuff in there. Let's say that you want a slightly more serious computation. You can go into computed variables. You can insert this over here, and here you have a formula. And this formula, it's just a more general interface. It's a bit like a transformation, but it really allows you all the other things. So for example, you can do things like if, then, so for example, if conscientiousness, where is it? Yeah, if this one is larger than 0.1, then do 2, otherwise it's not available. And then you can run this sort of thing. So all of those are larger than, then let's do it at 0.4. Yeah, so you can see some of these, all of those are larger than 4.5. Okay, so some of these are 2, or they're missing values, so NA over here. So you can do a bunch of things with it. It's just a regular function of R, and you can include all sorts of things in here. So for example, I can also do a computation based on this. So for example, I can say if F is a missing value, so for example, if this one over here is a missing value of this F thing, then it equals to 1. If not, it's equal to 2. So like if you want to play around with missing values, you can also do computations of variables like that. So already you can see that you can do some really cool stuff very, very easily with computations. The nice thing about this is that this is included already within the OMV file. So once you open the dataset, it will immediately dynamically open the computation, do all the computations and the transformations in order to give you the data. Another thing that you might want to do is that you might want to also include a filter. So let's say that you only want to run this on a subset. So for example, I want to add a filter over here. And this filter, I want to make sure that, in terms of F2, that F2 is only equal to 1. And what you see over here is that this filter will now have a plus sign or an X sign next to the row. And only the rows that are selected based on this computed F that I just did, based on something that makes absolutely no sense. But just like generally, you can do a filter on this. You can actually add a couple of filters. So for example, you can say only select things that are, say, this F2 equals 2. Of course, if I select both of them, because there's only 1 or 2 levels, but then I can really switch between them from here to there. Now, I'm going to show you how this is useful. Now I'm going to disable both of these filters, but I'll come back to them. Just know that right now we have these 2 filters based on something that we just computed. And I'm going to show you some analyses for correlations. So first of all, I'm going to show you what descriptives look like for continuous variables, just like this one. So it's always good to start with these things. So I'm going to add this over here, so we know these already, and then we can add all sorts of plots. So we can add things that we haven't looked at before. So we can add all these nice plots in order to look at how they're distributed. Okay, so you can see all of these. These are pretty simple and straightforward. There was another one that I wanted to show. Oh yeah, I wanted to show you the scatter plot. So if you open Exploration and you go into Scatter, this is the package, the module that I had to install. So Scatter adds this really nice scatter plot. And if I open the scatter plot, you'll see that I can have 2 of these continuous variables on a plot over here, and immediately it gives me this really, really nice scatter plot. Now, it can already add some stuff in it, like it can have a linear line. It can also have the standard deviation around this linear line. And another thing is that it can add densities or box plots. So it depends on how you want to look at this in terms of how you prefer to display it. It already gives you some really cool stuff. So this is already, I think, much better than most of the stuff that I've seen come out of the box for SPSS back in the days when I used to look at this. But just like doing a few clicks, you already have this remarkable thing over here. Let me see if there's anything else I wanted to show you. Let's do a correlation matrix. So I think that's one of the cool stuff that you can do very easily over here. So let's say that I want to run all these correlations. I'm just going to do this with the simple ones. So immediately it gives me this really nice correlations table, and depending on what your preference is and your APA style preferred stuff. So if you want your p-value under it or not, do you want the confidence intervals of the R? And I think it's increasingly more and more important that we display these things. You can flag them rather than, so if you want your stars in there in terms of the lower than 0.05, 0.1, or 0.01, so you can have these things in here to allow for like simpler, you know, abstract view of things. Another really cool stuff that you can do, and that's a really powerful thing with a single click, is that you can do a correlations matrix and then have this really nice plot over here where you can see for each one of these factors what is the correlation between each one of these, and then you can just like add the statistics. So for example, you see the plot in terms of the densities and how they're relate to one another, but you also have the actual correlations over here on the right side. So that's a really powerful one to have. If you want to also have the densities, it will show you this on the diagonal. So you can see sort of like the histogram of what it looks like for each variable with itself. So for extroversion, agreeableness, you can just see the way that it is. You can also decide on the direction of the correlation, so correlated positively, negatively, and so forth. So that's a really powerful way of doing this. Let's say that you want to look at the regression, a linear regression, so you can add this over here. Very, very easy to do this. So you have, let's say, two covariates that are predicting this dependent variable, and you can have a look at both of them and see the model together, and you can decide like what exactly is your model, and you can also look at an interaction. So you can add this to your model. You can have this in the same block, or you can add a new block where you actually first, look at these two factors, each by itself for a main effect, and then later in model 2, block 2, you add the interaction between them. So looking at each step, how much does this help in terms of the adjusted R square? You can also do all sorts of assumption tests, so autocorrelation test or collinearity to see if the factors are associated, and here they definitely are going to be in the big five. So some factors and assumption checks that really help you to make sense of things. Yeah, things are getting very heavy with this regression. I'm going to close this one as well. Too heavy for my computer. This we don't need. Now, what I wanted to show you is, let's remove this one as well. Okay, so let's say that we just want this like basic correlations matrix. So I'm just going to run this basic correlations matrix, add this over here. The one thing that I wanted to show you is that if I just look at this correlation matrix over here, I can actually go to the filter and say, I want this correlation matrix, but I only want it on the filter. Then I just like do activate this one. And you'll see that dynamically, it will show me my correlation matrix only on the things that I filtered for. So it's once you have an analysis, everything that you do in the filter affects everything in your analysis, which is why I deleted this, because if I wouldn't delete this and I would activate this filter, it will update all of my analysis, and then it might take like, I don't know, half a minute for things to get back to normal. So just so you know, you can make things active, inactive in terms of these filters over here on the left, and then immediately it will affect everything over here on the right. What does the dot next to the variable name mean? That means it's a computed variable. So this one, as you see, it's a transformed variable. So it shows this red one means that we use this transformation. This one is a computed variable. So these are variables that we got from our data set. This is a normal variable, and it's continuous in the sense that you see this ruler. If it has this dot, it's either a computed variable, so this dot over here, or it's a transformed variable over here with the red. So hopefully that answers that question. Right next to the yes. Okay. So we've seen that. Maybe another thing that I can show you over here is this mediation moderation. So I guess if you use SPSS, I guess you're using process by Hayes, Andrew Hayes. So he does a bunch of stuff. And I think one of the reasons people have a very hard time moving transferring to some others is because they got a little bit addicted with process. But have you ever tried to export the syntax for process? That doesn't go very well. The good thing over here is that we have this mediation moderation thing. You can do this with various sort of ways. So this one is a very complicated one. I don't think I'll go too much into it, but I just want to show you that it does sort of like a path model. So it uses, I think, underneath Lavaan SEM models, and you can add, you know, the mediators and the factors. So you can have like really nice model diagrams, and it will show you all the path in there, and you can do some bootstrapping. Like, this is a very, very powerful module. I'm gonna skip the more complicated one for now. There's some really good videos on this one. I'm gonna stick to like the simple ones, like a mediation over here. So let's say that you have these three variables, like a dependent measure, a predictor, and then you have a mediator. And then you want to see the direct, the indirect, and the total. So this is like a very quick way of you doing a mediation. You can also see the path estimates, you know, one leading to the other. And then you can also, with a single click, also look at the estimate plot, have some confidence interval, and then looking at a percent of mediation. So something quantifiable in terms of you saying what the mediation is actually offering you. And of course, I just chose these three kind of randomly, but already it gives you some really interesting stuff about the total, the direct and the indirect path, and the percent of mediation, as well as our cherished p-values. So very, very powerful in order for you to do mediation if you like interactions or moderation. So this, of course, allows you to do that as well. So we can also do something very similar here. For me, it's like adding this randomly. But you can already see that you can do very similar things in terms of simple slopes. So doing a simple slopes plot in SPSS is going to take you a while, but here you can very easily just like have a look of, you know, this nice plot over here. So for plus 1 standard deviation, minus 1 standard deviation, then looking at the simple slopes estimate, already in APA style table. I remember the PhD years for me struggling with SPSS, computing this, moving this to Excel, you know, using all sorts of scripts. It was painful. Like I really wished when I had JAMOVI when I started my PhD, life would be so much simpler. So yeah, very powerful stuff that you can do when you have continuous variables and you want to look at all the models. If you want more like process stuff that you're used to perhaps from SPSS, then you can use this JLM. You can also do much more complicated general linear models. I will not go into this, but let's say that you have a mix of all sorts of different types of variables and different, you know, independent variables, independent variables, and you want something more complicated. This is the way that you want to use your general linear model. I'll just show you very briefly the interface, just to show you like how advanced this model is. It really has endless things that you can do with it. So this is a very, very powerful module over here. Highly recommended that if you do complicated stuff that you'll get to know this a little bit better. Obviously, regression is very you know, limited in its ability to deliver the more complicated stuff in terms of mixed models. So this is worth checking out and seeing some of the things. We also have, I think, where did I see this? I think some of the courses that I included over here have some really nice tutorials on how to use some of these general linear models. So just browse a little bit through these guides that I have over here. Oh yeah, so we have like this really nice PDF that takes you through this model and explains everything to you step by step. So just like to give you a sense of how powerful this module is, it really allows you to do all of these remarkable things in terms of, you know, probate model, Poisson. So whatever you're looking for doing, depending on the nature of your variables, you can adjust this over here. So highly recommended. You need to install this model, and then you can just like start working with it. So there's a bunch of guides and things that you can also look at over here. What else do we have over here? So we've seen basic things for like correlational and experimental. There's other things that you can do here as well. For example, it's increasingly more common, especially in psychology journals, I'm not familiar with the other fields, for you to do something called a mini meta-analysis of your own studies. So let's say that you ran a few studies with correlational, and then finally you ran study 1, correlation X and Y, study 2, X and Y, study 3, X and Y, and now you want to deliver a general message to your readers. If you want to follow up on my research and you want to study the association between X and Y, this is the effect size. But for each one of these studies, you have a different effect size. So how do you summarize for your readers based on the 3 studies together? How do you summarize what the effect size is, the aggregated mean-weighted sample, the average of these sample sizes and the effect size that comes together from all of these. So we call this a mini meta-analysis, where we take several effect sizes and we combine these together. So it used to be very complicated to do this. I know this because I worked with 2 collaborators in trying to summarize some of our stuff for publications that we had, and this was 2017. So they were not familiar with mini meta-analysis, and they were not familiar with how to aggregate these sort of things. So I tried to show them, and I have one example for you for a correlational design. I have one example for an experimental design. So let's start with a correlation because I feel like that's the easy one. So this is from 2018. We published this in PSPB, and it's a very, very simple idea in terms of what the study is. So you have agency beliefs, it's something called free will beliefs, and so this is the predictor, and then the dependent variable is job satisfaction. So very, very simple stuff. We had study 1 with Taiwanese real estate agents, and then we had study 2 with American on MTurk, and then we had study 3 that looked at 14,000 people from 16 countries using the World Values Survey. So we had these 3 samples, and these 3 samples had effects. And the question is, once we had these 3 studies and all of them showed effects, can we aggregate these together? So each one of these studies, of course, you include everything in there in terms of, for each country in the 3rd one and all that. But the question is, if we want to aggregate all of these together, what can we do? So if we look at the summary table over here, we have study 1, time 2, then we have study 2, time 1, time 2, and then we have study 3. And they show different effect sizes. So for example, over here in time 1, it was this effect size, in time 1, this effect size, in time 1, this effect size. And then we want to aggregate these together. You'll see that in this table, we have something called a mini meta. So if we aggregate all the time 1, all these 3 effects together, what is the aggregated effect size? And the effect size needs to take care not just of the average of these 3, but it also needs to take into consideration the sample size over here. So back in the day, when I was trying to do this, there was a way of computing this, but I wanted to share this with my collaborators and show them how to do this. And it was fairly complicated back then, but I wanted to do a simple interface that would allow them to see what it is that I've done. So first of all, I created CSV files to summarize these effects. So if we just open with Excel, these CSV files, so comma separated, you'll see I just summarized this very, very easily. Study 1, this is my n, the sample size, and this is my effect size, so the correlation. So looking at all these 3 together, how do I arrive at the effect size? So I was trying to think back in 2017, how do I do this? I know how to do this in R, but my collaborators, at least one of them is not very proficient with R. So how do I best do this? And this is another thing that I want to show you with R. So I wrote my first Shiny app. It took me about an hour to kind of get this working together. And finally, I decided I'm going to allow them to simply take my CSV file and upload this to R, and without them knowing R at all, they don't need to know anything about R, they'll be able to run my analysis for the mini meta. So this is the kind of code that I wrote. It's a very, very simple code. I copy pasted this from some snippet online, and then I just made adjustments to the interface. I'm just going to show you, ignore for a second this code and how to create it. I'm just going to tell you that if you know R, it's very, very simple. But you'll see over here on the top, there's something called run app. Let's run this app. It's called a Shiny app. So let's run this R Shiny app and see what happens. So as you can see, this Shiny app has a really interesting interface. And the nice thing about these Shiny apps is that you can very easily create your own interface. And what this does is that this is a mini meta-analysis of your own study for correlations. And the only thing, once I had this interface, the only thing that my collaborators needed to do is have a CSV file where they can upload, and it needs to have these columns. Once they have these columns, I do some stuff with R underneath that will show them the meta-analysis results. So let's load this CSV file. So I'm going to load this into my Shiny app. So I'm just going to browse. I'm going to go. OK, so it's already in here. I'm going to load the time one. Once I load the time one, you can see the CSV is first of all displayed over here. And immediately, it does the mini meta-analysis result. So it gives me the mini meta-analyzed effect size overall is a correlation of 0.027, and this is the lower confidence interval, the higher confidence intervals, and then you also have this forest plot that kind of puts them together. So you see the confidence intervals, you see the middle point, the effect size. It's much bigger for study 3 because it's 14,000 participants. So the confidence intervals are much more narrow, and then underneath you have the aggregated effect size of the 3 studies together. So finally, I have this 0.28 that now I can take, and I can put this in my manuscript and say, if you follow up on the relationship between free will beliefs and job satisfaction, and you want to do a power analysis, I think this is a good estimate of an effect size. And when we evaluate effect sizes, 0.28 is a fairly strong effect over here. Yeah, so this is back in 2017. I thought that I was really clever and I was able to do something amazing. And then Kyle Hamilton came in. I'm going to open my browser, so I hope my Zoom survives. Let's try this. Okay, hooray. So far, so good, I hope. Okay, so what Kyle did is Kyle had an interface that he wrote a Shiny app that makes mine look ridiculous. So if you want to do your own meta-analysis, it could be a mini meta-analysis, it could be a real large-scale meta-analysis. You can just look at the Mavis. So Mavis is a Shiny app by Kyle Hamilton over here. So it's amazing. It's just outstanding. When this came out, I just thought, oh my God, it's you know, groundbreaking. Since then, he's done all sorts of other wonderful things, but at least for this one, I can show you what this looks like. So let's look at a correlations example. So you can choose if you want to do this on a Cohen's D, want to do this on correlations or dichotomous models, whatever that is. I'm going to take one of these examples. So we want the example over here for correlations meta-analysis. So I'm going to copy this example and I'm going to go one to the main. And you can just like a CSV, you can also copy paste this from a CSV. You can just like put your stuff in here. Not only your study, your N and your R, but you can also add a moderator. And then immediately, as you put this here, if you do update view, you can see over here it does all sorts of rendering. This is R working under the Shiny app, doing all sorts of computations. And then if we go down here, it does all sorts of amazing things. So it transforms this to Fisher Z, and it gives me all the fixed effects models. So finally, I have this conclusion of a fixed effects model, a random effect. It gives me this wonderful plot that I can download as a PDF. It's just wonderful. Well done, Kyle. It also gives me some publication bias analyses. So for example, over here we have trim and fill, so you can see how many are open circles are missing on the left side. Also to funnels, lots of estimations of a publication bias. And it also gives you a moderator analysis. So you can see, I don't know if you noticed this before, but we had the moderators of is it mixed, is it boys, is it girls, for each one of these studies. So if we go over here, we also immediately also have a moderator analysis. So this is lovely. Wonderful plots, very, very easy. The only thing that you need to focus on is just like summarizing your own studies, putting in the correlations, and finally being able to deliver to your readers what the aggregated effect size is in all of this. Now, in addition, of course, you have these effect size calculators, wonderful stuff that you can do with this. Now, you might be asking yourself, so why is he showing this to us now? Okay, so it runs on R, so what? But Kyle also did a module for JAMOVI. So the problem with this thing over here is that it's not very reproducible, in the sense that if you want to share this with your readers in terms of what did you run, you would need to do screenshots over here or download the PDFs and all this. So it's not ideal. Let's say that you want to share, just like JAMOVI does. You want to share the raw data, you want to share the syntax, you want to share the output, everything together. You can do this now in JAMOVI. So if we'll go back, let's just close this. Let's close this. Oh, actually, let's keep this one open. I'm going to close this one. Yeah, let's start a new one. Let's do, I hope this will be okay. Yeah, so we have this JAMOVI open. What we can see over here is that we have this major thing over here. And what you can see is that you have different ways of doing a meta-analysis. So let's start with this one over here, this correlation coefficient. If we open this, you'll see that it allows us to run, so it allows us to specify these things over here. So what I'm going to do is I'm going to kind of copy this in here. And then I'm going to just say, like, this is study, and this is Rn, and this one is my effect size. So now I have these, and I can start like punching these in. So I can add this effect size and correlations. Empty. Why is empty? Which one is empty? What did I do? Oh, yeah. Okay. This one is continuous. Let's go continuous. Yeah. Okay. So as you can see, the variable type is important. So don't forget. So if something doesn't work, it's probably has to do with the way that you've defined things, and this is obviously you know, just an ID. But anyway, so you have an effect size and that's continuous. You have an n that's continuous. It's an integer. This is decimal. Okay, so now we're back to normal. So I just took exactly the same thing. And if you remember, my very simple shiny app from 2017 just looks ridiculous compared to how nice everything is over here. So you have your data, it's included in here. You have your correlation coefficients, and you have your forest plot, and you have all your publication bias assessments. So really cool stuff. You can add all sorts of remarkable things in here in order to play with this model. Model fit, everything else that you want in there. So that's really nice if you want to do a meta-analysis, a mini meta-analysis. So it used to be, you need this comprehensive meta-analysis data set. You need a lot, to pay a lot of money, or you need to know R. But now with this JAMOVI, you have this really nice thing over here, and you have all sorts of stuff that you can run. You even have a Bayesian meta-analysis. Not gonna go too much into it, but it's increasingly, I've had more and more reviewers that say, but you need to do this in order to get that. Okay, so now you can plug this in here and do that as well. There's another module that allows you to do a meta-analysis. So for example, over here, this meta-analysis R also allows you by ASCII, and it gives you other options. So this is an effect size person. So also another one that gives you like a really nice summary, the diamond ratio and everything else, and you can have like a really decent summary of the whole thing. So by now we have two really nice options in terms of you conducting a meta-analysis within JAMOVI. So if you save everything, it's going to save all the outputs, all the data together. So in the JAMOVI, in the folder, the workshop folder, I have some examples from our experimental. So this is one, another manuscript that you can see an example of how to do this. And I'm just going to show you, for example, what it looked like. Yeah, so you have the JAMOVI files over here, and you have the R file. So you can do a bunch of things with it, decide to use this as best you want. So where are we right now? So we are, oh, 3:30. Okay, so we're getting kind of like towards the end. So I feel like I should show you some stuff with other programs. Can I know how to handle the non-independent effect size? Can you explain what you mean by that? What do you mean by handling the non-independent effect size? I'm not sure what that means. But I think we're gonna wrap up. Oh, okay. I didn't show you this, but there's also like if you want to see our reliability. So my computer going to survive? Yes. Okay. So you can do a reliability analysis of any one of these factors over here. So if you have different, let's just assume these are items and not latent constructs. So you can add these over here and then see the Cronbach alpha. Obviously very low for this one because these are not, they're not items of the same scale, but you can do some really complicated stuff in here, but also look at like a correlation heat map in terms of like how they're related to each other. But if you have a scale, you can very easily do a reliability analysis, but you also can do, I think, exploratory factor analysis and a principal component analysis. That's pretty straightforward, but confirmatory factor analysis, that's pretty amazing because I don't think there's the simple way of doing this in some of the more sophisticated software. And if we want to have a look at some of these examples over here, so we have like this confirmatory factor. So here you can see a confirmatory factor analysis, which is amazing that JAMOVI is able to do this. So you don't need to know too much in terms of like, and it also gives you like the SEM path diagram, which is remarkable. So there's all sorts of things that you can do over here in terms of, what fit measures you want and what your estimates is, and, how do you control for all sorts of things. So very powerful, out-of-the-box conformity factor analysis within JAMOVI. So well done, JAMOVI. Okay, conventional meta-analysis procedures assume that effect sizes are independent. Oh, yeah. That's one of the things, yeah. That's one of the things that I think Kyle was working on for Major 1.2 right now. There's no way to do this, but I think in his next version, he's looking at like how do you collapse within a study. I think he's also working on multi-level meta-analyses. So he's building this up little by little, and I already know that it's in active development. So these things are coming. You can go on his GitHub. If there's something specific that you want, he's very responsive to requests. Generally, I want to say the JAMOVI team is incredible. So we've had a few issues. So for example, with post hoc effects, we first found a little bit of a glitch, and that's a nice thing about open source software, that you can find things easily because everything is open shared code. And we reported this, myself and the students that are working with me, and within an hour, we received, first of all, a description, an interaction, and then a solution that helped us, plus a bug fix. Within the next morning, they already released a bug fix for everything else, plus 2 added features that we had. So Jonathan Love and the other JAMOVI team, super responsive, very helpful, and also they implement stuff. So almost everything that we've asked them, I've asked them. I think we were one of the first back in 2018 when I joined HKU to implement JAMOVI on a large scale. And I told him, in order for us to be able to really run this in our classrooms, we need this feature, this feature, this feature. They really implemented everything within the first semester that we asked them. So if there's something in, let's say, the meta-analysis model, if you want to talk to Kyle, or there's even something in the JAMOVI that you need or you want, or if you identify some bug, please post this on their GitHub. Immediately you will get a solution or at least an interaction to try and understand things. Sometimes it's, I post things that end up being very silly, and then they say, but you didn't try that. And I'm like, oh, okay, so my bad. But they respond. Also, the GG stats plot developer is very responsive, so he does a lot of very, very interesting models. So I encourage you, if there's something that you need, to go in there. The more people that ask them, the higher it goes on the queue in terms of addressing this. But generally, yes. So definitely, if you have multiple effects within a single study, even if it's, like I said, within design, then there should be soon a way to either collapse those or do this in a multi-level analysis. I think this version still doesn't have that, but I know it's coming because I've discussed this with Kyle a few times. All of these developers are very active on Twitter, as I am, so you're very welcome to engage with them. So I can't remember, somebody asked me something about inter-rater reliability at some point. Anyway, we don't have a lot of time, so I'm gonna push this aside. But you can deal with a lot of different types of analysis. So we're getting to the end, but I still haven't even shown you JASP. So I feel a little bit bad about that. Let me just see very briefly what I want to. If there's anything else that I wanted to show you here. Okay. Maybe next workshop. I want to show you one more thing about R, but we'll leave this to afterwards. Okay, we'll wrap up by showing you, so I don't disappoint the JASP folks. Almost everything that we've done in JAMOVI has a version in JASP. Okay, still on? Yes. Okay, good. So JASP. Perhaps looking at JASP, it looks familiar to you. It's because at the beginning, JAMOVI and JASP were the same team, but they forked, they split, which sometimes happen in the open source community, like with the different flavors of Linux and editors of all sorts. So it's actually good for the community. They're not directly competing with one another, but I think there is sort of like a comparison of some sort. But you can see it looks very, very similar. A lot of the things that we just saw in JAMOVI are also available here. The nice thing about JASP, the reason why they forked is because JASP is done by Bayesians, and they really emphasize at the beginning Bayesian analysis. At some point, JASP realized that if they're only going to be Bayesian, nobody is going to use this aside from the Bayesian folks, and they wanted this to appeal to everybody else. So the Amsterdam team that's developing this decided that they're also going to implement frequentist stuff, just so that they can convert everybody to Bayesian at some point. Now, JASP is not as how to say, open as JAMOVI, so there's no external models that can be implemented in this also, although I think they're working on this. Also, JASP, and the reason why I don't use this in my courses yet is because JASP, as of now, does not export the R code, the syntax underneath, even though it runs on R. But there's some stuff that it does extremely well. First of all, it's a lot smoother than JAMOVI, so it wouldn't kill your computer. It also has things much better documented. So if we look at the data library, first of all, you see for almost everything, you have these amazing data sets. And unlike JAMOVI, here these data sets come documented with what they've done. So it comes with a lot of built-in instructions. So it will say, at least for this data set, this is political democracy. These are my variables. This is the reference where I took it from. And it's really nice because it gives you everything that you would expect from an SEM model. It also helps you to kind of understand how this is specified. So this is a very simplified syntax from Lavan that I think anybody that understands SEM can identify with. It also allows you to do all sorts of things like add all sorts of statistics, R statistics, do some bootstrapping, everything that you would want over here, plus allow you to insert a path diagram that you can actually take as is. So even if you're like programming in R and you're doing your path diagrams, it's a really nice way, a really nice interface for structural equation modeling here in JASP. Also, if you want to do some stuff like with a Bayesian meta-analysis, this is a little bit more complicated than the one that's built in with Major in JAMOVI. I didn't want to open this one. I also want to show you that there are some other models that I don't know how to use very well. But let's say that you want to use, let's say, machine learning or network analyses. So these are some very complicated stuff that you can do very easily within JAMOVI. So if we go over here and we open some of these data sets, I hope that this will work. But you have some examples of how to do, let's say, for example, from the big five, how to do a network analysis in here. So JAMOVI has features that JASP doesn't have, and JASP has some features that JAMOVI doesn't have. So it depends on what your emphasis is. You can use both. So we're kind of towards the end. I think we're almost wrapped up our 3 hours. I want to open this to you. Is there something that you want to ask me before we kind of disperse and go our separate ways? Something that you want to bring up, some questions that you have about JAMOVI or R or JASP? Sorry, I may have missed that part. Can we run a mini meta-analysis for experimental studies with Major, like the Shiny app developed? Yeah, so definitely. Yeah, so I don't know which Shiny app that is, but Kyle is the one that did both of these. We wanted the experimental one, so we can go over here and like open one of. Okay, so what you can see over here is on the left, you have two conditions. So two conditions, condition one, condition two. So the sample size of the first, the mean of the first, and the standard deviation of the first, sample size and mean standard deviation of the second, and also an estimation of the effect size. If you want it, it will compute this for you. And what you can see over here is that if you click on this, actually, it just runs the Major mean difference one. So you can do this over here, mean difference, or you can do effect size or sampling variances. But the mean difference is kind of more suitable for what we have over here. So you just insert all of that in here, and it gives you a summary of all the stuff, just like in the Shiny app that I showed you from Kyle, the Mavis Shiny app. So either correlational or dichotomous, or if you're just effect size or proportion, almost everything that you have on the Shiny app in Mavis, you should have over here, and the other stuff is in very active development. So I hope that's what you meant, but yeah. So all this is available in the ASCII. There's also here you can do a correlation, or you can do raw scores, or you can do Cohen's d, or you can do R. So either with ASCII or with Major, you can run this meta-analysis. Another question: would you mind sharing about how you use R JAMOVI JASP efficiently to conduct the analysis? Just wondering, it will be quite annoying to experience some crashes to use these three software together. I just want to emphasize the reason why I'm having crashes is because of Zoom. It's not because of the JAMOVI and JASP. I honestly, I try to use R. I made it a priority for myself. So recently, I don't do a lot of projects by myself, but at some point in 2018, I committed moving completely to R. I think it's the right thing for you to do. But if you don't feel comfortable about this and you have collaborators that need a little bit of a jump start and you want to transition slowly, you can use JAMOVI. I would say that if I want to do something very, very quickly, let's say that I have a data set, I have a very specific thing I want to do, like descriptives, then I maybe do this with JAMOVI. But increasingly, everything that I do in my projects, I try to do with R, not just R, but R Markdown. So that's the last thing that I wanted to kind of show you from this workshop, but I don't think we have time. Maybe I'll just do another workshop about R and R Markdown, and I think the future of science, of how I think manuscripts are going to look like in a while. I'll definitely do a workshop on this. So I'll keep you posted if you subscribe to the mailing list, or keep an eye on the YouTube channel and all that. Then you'll get a notification. But increasingly, I try to move everything that I do to RStudio. Also, starting from the next version of RStudio, it will also have just like a regular editor. It will look a little bit like Word. So not only will you have code, but you'll be able to edit sort of things. So within R, within a few clicks, you're able to produce automatically an API-style manuscript with everything built in according to standard. So once you know how to do R and R Markdown, and you know how to do this well. So somebody showed you not, start doing code. I think this is how we train our students, and they get scared and frustrated very easily. But you show them the easy way out, and you show them the immediate benefits of doing R and R Markdown. And I think once you understand the power of R and R Markdown, you don't go back. The little that I use out of JAMOVI, I try to immediately export with the R syntax to R. Now, it's up to you what you want to use, what level you want to keep at. If you're, let's say, a graduate student and you're building on a career, if you even don't want to be an academic, you want to be a data analyst somewhere down the road, I think you should transition to R. For me, I use JAMOVI when I run things in my undergraduate classes, because many of the students coming to my class, second year or fourth year, depending on what, or third year, some of them in the JDM class, are not familiar with statistics. R is very scary for them. It's already a bit overwhelming for them. What is an effect size? What is confidence interval? So with JAMOVI, they're able to get all this information immediately. So when I work with people who are in their basic level, I try to work with JAMOVI. I don't know why our entire scientific community is addicted to stuff like SPSS and Stata and SAS. I really hope that we'll get rid of this addiction. And I'm really grateful for the JAMOVI folks that help us to kind of build this SPSS-looking interface on top of R. But I don't think it's the right direction long term. I think you'll just use it as transitioning to something else. I hope that answers the question. I don't know. How do we get on the mailing list? Okay, so let's wrap this up, and I'll just I hope it's in the last. Yeah. All right. So these are my details. Everything from my website. You can look over here and scan this or go on my website. I just want to say, we in the open science, open source community would like to help. And I'm serious when I say this. I'm not just saying this in order for you to think, okay, yeah, he said this at the end of the lecture. I want to really say, I don't know who the 100 and something participants were, who the 70 are right now, but I do want to say this. If there's something that you're not sure about, if you don't know how to do something and you're stuck, you want help, we want to help you. It's very important for us that everybody in our community and beyond is able to improve their scientific practices. So everything that we do is open, shared, and we try to add as much as possible, work together collaboratively in order to help one another. So if you're feeling stuck, if there's something that you don't understand, then please reach out. Even if I'm super busy and I can't help you with a specific question, we have a lot of people working together, so I can definitely get somebody else to help you with this. But most likely, is that the question that you ask, I'll be able to just provide you with a very quick link to a solution that we've already had. So I didn't mention this, but at the beginning, me coming to HKU, we started this mass replication project. By now, we've completed about 72 of those. Plus, on top of those, we have about 30 or 40 other projects that are running in the background. Plus, this semester, we're doing 20 more. So in the 2-3 years here at HKU, we've had a lot of people involved, completing over 100 of these things. And through that time, we've learned a lot. Not only did we finish these scientific projects, but we built the foundations by doing collaborative guides, by having open source, open code, sharing everything with the community. We have solutions for a lot of things. I think by now, we ran into most of the issues that an undergraduate would come across if they would try to pick up statistics or do stuff in a scientific project. So most likely the questions that you have, we've answered at some point. So reach out to us, let us know how we can help. We'd love to have you involved in some of our projects if you're feeling like it. And we'll have more of these workshops later on. So you can see over here this mailing list. So if you're on this mailing list, then you'll get some updates about, first of all, what kind of projects we have, how you can get involved if you want to be a collaborator, a co-author, what kind of resources we have in terms of videos, guides, but also if we have more workshops, or we're running fun stuff like prediction models, to paid prediction models where you can get $50 to help science in terms of whether something will replicate or not. We have a lot of activities, and all of them are on this mailing list. You can also browse this mailing list to see what we've done before, but there's a lot of ways for you to get involved and keep up to date. So I want to end this by thanking you for joining us. Hopefully this would kind of set you on the path for feeling more comfortable with both JAMOVI, JASP, and R. And I hope to see you next time in the future workshops. So all the best.